This is a brief and quick introduction to NLTK. I assume you know Python fairly well, or okay, and I will assume that that you have Python installed in your computer. So I'm going to work on version of Python 2.7.12, but you can work on version 3. Whatever. It also works on this. This tutorial works on both versions. So the first thing you do is to install NLTK. I would direct you to nltk.org to find out how to install NLTK in your platform. It's usually just a matter of opening a command line or a shell, however you want to call it, with and then type the commands pip install and then NLTK. If that doesn't work, I'd refer you to nltk.org. Okay, now I'm in the Python shell, right, which you can access with your either idle interface on a PC or just from the terminal. Type Python on PC and on Mac or on Unix. So we're in the shell. The first thing we do to work with NLTK is to import the package. So we'll say import NLTK. I'm assuming you have it installed. The first time you import NLTK, one thing you will have to do is this, nltk.download, okay, which will allow us basically to install a bunch of packages that are important for NLTK. So you'll see this window pop up with this in either green or red or yellow. Click on all, click on download, and then wait for it to download. Once it's downloaded, you can say finish or okay, and then you are good to go. You only need to do this the first time you import NLTK in your computer. All right, so what can you do with NLTK? Well, NLTK has a lot of corpus, a lot of corpora in it to help you build your own classifiers, find out stuff about words and whatnot. So let's explore some of that. So what I'm going to do is from nltk.corpus, I'm going to import the brown corpus. It's very common, so very widely used, so I'm going to import the brown corpus. One thing that I can do with the brown corpus, I can see the words. For example, I would say brown.words, and I'm just going to display the first 10, otherwise it's going to be a mess, right? And here are the first 10 words of the brown corpus. You can see it's simply a list that you can access and do whatever you want with it, right? In a Python way. You can also get, because of the nature of the brown corpus, you can get brown.tagged words, okay, 0 to 10. And what this will do is it gives you the same 10 words, but in a tuple where the first element is the word and the second element is the tag, right? So the is AT, Fulton is NPTL, investigation is an N for noun, and so on and so forth. And the U next to each one of the elements, all the U's, that means that it's just a Unicode string. So no big deal there, it's just a string. Now, you can also, you also have, like you said, you have corpus that is trained on something, in this case part of speech tagging. But you can also have more of a raw text sample of data. So you can say, for example, from nltk.book, let's import all the books, all the text corpus that NLTK brings with it, so we can do stuff. So it's importing, you see it's importing Moby Dick in a variable called text1, Sense and Sensibility in a variable called text2, Monty Python and the Holy Grail in text6, inaugural address corpus in text4, and so on and so forth. So it brought back 9 different corpora. Now we can explore this. These are text objects. Okay, if you want to look at the documentation, is this kind of object. So the variable text1 holds Moby Dick, right? So I can do something like this: tokens, and then the first 10 words of Moby Dick. Whoops, I'm sorry. Tokens without the parentheses, 0 to 10, and that gives you the first 10 words of Moby Dick, right? The first 10 tokens. So this is a token. This is not starting a list. It's just a character that happens to be in the book, okay? So you'll see that you can get all the words from any of these corpora, right? To Python and the Holy Grail, you can just do text6.tokens 0 to 100, whatever, right? That's the words. Now, you can do, and then you can do whatever you want with this corpus, right? Another thing you can do with NLTK is tokenize text, your own text. You bring your own text. We want to create the tokens. We want to also look at the sentences. So we're going to import some NLTK functions that are very good for this. So from NLTK import sent tokenize. That will allow us to extract sentences from text. Word tokenize will allow us to extract tokens or words from text, and post tag will allow us to part of speech tag words, okay, in a vector of words. So let's look at each one of these in detail. So let's say I have my own text, okay, and my variable, I'm gonna have a variable that will hold some text. So for example, my text, and that's going to be equal to some text about machine learning. Okay, so this is a big text. Machine learning is the science of getting computers to act without being explicitly programmed. In the past decade, machine learning has given us self-driving cars, practical speech recognition, effective web search, etc., etc. This is a little paragraph. So let's look at what are the sentences in this paragraph. So if I do sentences equals sent tokenize my text, and then I want to see what sentences is, you see that it now became a list because it starts with braces, then simple quotes all the way to the closing quotes. That's the first sentence, comma, and then the second sentence here, it's here, comma, and then the third sentence, and so on and so forth. So I have separated this in sentences, and I can work with this as with any Python object, right? So I could do len sentences, and I can find out how many sentences are there, 7 sentences. In the same way, I can also get the words. I'm going to call them tokens. You will see in a second, because it's not only words, but it would be word tokenize my text. So this is my text, right? I'm going to tokenize this. So just the words and other tokens. So let's look at the tokens individually. And you can see that every word is a token. It does a pretty good work of dividing the words, but also gives you, like, for example, periods. So you can go word by word and knowing where the period is, knowing the position of punctuation in the text, but it doesn't mix up, it doesn't mess up your words. Like, you're not going to have a programmed period word, right? So it detects the words, it removes punctuation, and it puts it in its own token. So this is very useful. Now, you can do many things that you would do. Again, this is a list, so you can perfectly do the word or token to lower, for example, the lowercase token for t in tokens. This is a regular Python for loop. It's going to go for all the elements of tokens. I'm going to call them t, and I'm going to create a list with just them in lowercase, right? And then you see that my tokens moved from machine uppercase to machine lowercase. Everything is lowercase, and I have standardized it for whatever task I want, right? So we can extract tokens, we can extract sentences, but we can also tag words. So this requires a list of words to be tagged. So for example, I'm going to tag these tokens. So I'm going to say tagged tokens is post tag of tokens. So POS tag takes a list of words, okay, a list of tokens, and then it provides another list with the tagged tokens. So we can see tag tokens, and we can see that machine is tagged as a noun, learning is tagged as a noun, is tagged as BBZ, the dt for determiner, and so on and so forth. So I have a list of tuples where the first element is the word and the second element is the tag that it finds for this, right? Now, this is a pretty good tagger, but you can use other taggers and other tag nomenclature if you want. I'm not going to cover that here. I just want to show you that you can tag and work with these. You can train, you can look at a text and tag and do something with it, be smart, however you want to go with it. Okay? Now, another common thing in natural language processing is to look at words that happen with other words in the same area, right? And for example, you can see that, for example, let's say, let's look at a text object, right? And what we can do is look, let's say, to Moby Dick. So we can see Moby Dick words. Okay, that's going to be that's the text, and I can do Moby Dick's words dot similar to monster. Oops, I'm sorry. Moby Dick is text 1. Similar monster. Let's see what words happen around the word monster in Moby Dick. So, whale, ship, sea, world, boat, Pequod, whales, right? These are words that happen around monster. Let's look at, again in Moby Dick, words that happen around the. His, that, their, my, is, some. Let's look at words that happen around travel. Hit, them, break, what, queequeg, whom, encounter, Starbuck, watch, bring, and so on and so forth. Now, here's what we notice, a few things. So these are words that are associated to monster. These are all nouns, right? Words associated to the, these are all like meaningless words that are either, pronouns or modifiers, but nothing, I mean, just like in the same category of words as the. And if you look at travel, right, you see for the most part verbs, right? Snarls, ignite, have, break, inspire, right? Show, encounter. So these help you find like words in one sense, right? This is basically looking for the co-occurrence of this word with the words before and after it, right? Now, if you want your own text, right? Because this is a text object. If you want to create your own text object, you can do it. So you can say my text object, and I'm going to use the machine learning text to create my text. I'll do NLTK.text, right? And then I need all the tokens in my machine learning text. So tokens, and then I can do the same thing. I can do similar to machine, and then of course there's nothing because there's only one occurrence of machine, right? So, but if you had a larger corpus, or if you want to put them all tokens in lowercase or whatever, you create a text object like this, and then you can get a lot of, look at the text object in NLTK. There's a lot of properties about that object that you can get by making it a text object. Another thing that you might want to do in natural language usually is look for probabilities of words, okay? And this becomes really interesting. So for example, or probabilities of tags, or probabilities of tokens of any kind. So one thing that you can do is to get all the trigrams, right? All trigrams for text. So you can say, for example, T for trigrams is going to be, or my trigrams, it's going to be NLTK dot trigrams and then my TO. That's my text object that I just had before, right? Dot tokens. All right. So I go there. Now this trigrams is not a list, but it is a generator object in Python. Basically, you can build a list by doing this. A for A in my T. And then you get all the trigrams from this text. Machine learning is the science, and so on and so forth. So you can use my T as an iterator here to generate a list. Now, let's do something more interesting with trigrams, and this little text is not going to allow us to do it, so we're going to use Moby Dick for this. So let's do my trigrams. I'm going to use the variable trig is nltk.trigrams, and then here I have a lot of text. This is Moby Dick tokens. So I'm going to create this trigram set, right? Now, I could iterate and show you all the trigrams, but I want to do something else. I want to compute now the probabilities of the conditional probabilities of trigrams. So for example, what is the conditional probability of, I'm going to try to compute, this is not a Python anything, it's just to tell you, I'm going to try to compute the probability of word 2 given word 1 and word 0, right? That's what I'm going to try to do, which is another very common thing here. You use this to compute the probability of a sentence, what's the next word that's the next possible word, and so on and so forth. To do that, first I need to create pairs. I'm going to end up with, and this is the important thing, I'm going to end up with a dictionary in which you give it a bigram and then another word, and it'll give you the probability. So if I want to compute the probability of word 2 given word 1 and word 0 and word 1, if this is what I want to compute, okay, what I'm going to end up with is a dictionary that to which I will be able to say, let's say my dictionary is called P, which I will be able to say probability of the tuple word 1, comma word 2, right? I mean word 0, comma word 1, and then I will say give me the probability of word 2. This is the command that I wanna create. So I'm gonna create a dictionary with word 0 and word 1, and I will ask what's the conditional probability of word 2 given word 0, word 1. This is the notation we're gonna use. So let's start. I have my trigram, so I can do this, right? So first I need to build this dictionary, or this kind of dictionary. So I'm going to build a generator like this. Pairs is going to be word 0, comma word 1. Close that tuple, that's the first tuple, and then this is the conditional part, and then the actual word of the probability, word 2 in this case, right? That's what I'm going to extract for word 0, word 1, word 2 in trig. Okay, so again, I'm going to construct tuples here that I will put in this pairs, right? I'm going to construct a generator here where I will look for every trigram in trig, get the first word here, second word here, third word here, and create this kind of object, a tuple with the first 2 words and a tuple with the last third word. I do that. Now, what I want here now is get all the frequencies. So I'm going to create a variable called frex. Frex will be nltk dot conditional freq distribution, conditional freq distribution of these pairs. What this is going to do is it's going to go and count for every one of these pairs and look for every word that occurs with these pairs, and we'll be adding it, okay? So that's the frequency. So for example, we can look at some of the, I name it fix, okay. I'm gonna use that then. Fix.keys, this is a dictionary too, sorts is an actual object, but let's look at the first 10 keys of this. You can see it's ocean, comma, he shipped, every kind. So every kind of would be a trigram, right? But this is the bigram that comes before. This is word 0 and 1. Every kind, so it's a set of those words. And then you can also see, for example, what is associated. So let's look at every kind. You can say, for example, fix of every kind. And we see that every kind whatsoever, that's the only word with there. We can look at what happens after Moby Dick. What are the possible trigrams starting with Moby Dick? It can be Moby Dick, comma, another trigram, and there's 11 of those. There's another trigram here with Moby Dick, period, and there's also 11 of those. There's Moby Dick had, there's 5 of those. Moby Dick was, there's 5 of those, and so on and so forth, right? So you can see here, frequency distributions, right? And you can get trigram frequency distributions, and you can create your own model of probabilities here. Now, however, NLTK can make this easier even if this frequency distribution, you turn it into a probability distribution. So one thing that you can say, for example, is the probabilities, I'm going to store it in a variable called probs, is NLTK dot conditional probability distribution. The variable that I have, in this case, FEQS, fix, right? And then a statistical model. Just go with this. This is very safe. ELE prob dist. There are several probability distributions in LTK. Just use this. This is very similar to the maximum likelihood estimator, or this is very similar to the count of the words. You know, the count of the trigram divided by the count of the bigram that preceded it. So we get the probabilities, and we can look at, say, for example, probability of Moby Dick, and then the probability of the word was after Moby Dick. So what's the probability of was given that the previous 2 words are Moby Dick? It gets me that probability. If I want to do a probability of a sentence, it's very easy to do this, right? Now, if you want to do smoothing, you can do the exact same steps, but you will need the bigrams, right? So for the bigrams, again, very similar. You just do, say, bigrams equals NLTK dot bigrams text1, which is Moby Dick tokens, and then take it from there. The commands are exactly the same. You build not a pair in this case, but a tuple, right? So then you'll build, I will say, variable BB, for whatever reason, is word 0, right? Word 0, and then word 1. This means that I'm going to store word 1 given the previous word. That's a bigram model, right? Comma, word 1 for word 0, comma, word 1 in BIG, the bigrams, right? So I do that. Whoops, invalid syntax. Why is that an invalid syntax? Doom, doom, doom. Oh, because I need another one of these. There you go. All right, so I have now the bigrams, and then I can get now the frequencies. So B frequency, bigram frequency, will be NLTK dot conditional frequency distribution, right? And then BB in this case. It's building a bigram model, right? Bigram frequency. And then I can do bigram probabilities is basically NLTK dot conditional probability distribution, and then it's my bigram frequencies with NLTK dot ELE probdist. And I can ask, for example, what's the probability, so BP, the conditional probability, given Moby, okay, given Moby, that I will have, following that, I will have the word tick with capital letters. All right, so there's a 98% probability of the bigram Moby Dick. Now, it's not 100%. That's kind of weird, right? That is kind of weird. So why don't we look at the frequency, BF is where my frequencies are, of Moby. What words happen with Moby? Oh, Moby and then a dash in one occasion. So maybe it's when it says Moby and dash, right? For whatever reason. So you see you can get probabilities of trigrams, frequency distribution of trigrams, right? You know that, for example, here is Moby Dick had, the frequency that's 5 had with Moby Dick, right? So, and then the bigram Moby Dick here is 84 times, right? You can get this frequency, you can get these probabilities, you can tokenize text, you can parse speech tag, you can do a lot more, and you can customize most of this stuff. So this is my intro tutorial to NLTK.